Good day, everyone. I hope you're all doing good as of the moment. This time, I'll continue with the discussion about operation on rational algebraic expressions, specifically about multiplication and division. When two fractions are multiplied, we multiply the numerators of the fractions to form the new numerator, and we do the same for the denominators. This is the same with rational algebraic expressions. If there are common factors in both numerator and denominator of the two rational algebraic expressions, then we may cancel them before we multiply. Illustrative example number 1. Find the product of 2s over 4k and 3 over 2k squared. You can cancel the common term in the numerator and denominator. Cancel the common factor 2. Then multiply the remaining factors. S times 3 equals 3s and 4k times k squared equals 4k cubed. Therefore, the product is 3s over 4k cubed. In division of rational algebraic expression, we follow this rule. P over Q divided by R over S equals P over Q times the reciprocal of the divisor, which is S over R, where P, Q, R, and S are polynomials in one variable, and Q, R, and S is not equal to 0. Illustrative example number 2. Find the quotient m over 2 divided by m minus 2 over m minus 1. First, get the reciprocal of m minus 2 over m minus 1, which is m minus 1 over m minus 2. Second, rewrite the equation and change the operation to multiplication. We have m over 2 times m minus 1 over m minus 2. Third, find the product of the given expression. Then we have m over 2 times m minus 1 over m minus 2 equals m times the quantity m minus 1 over 2 times the quantity m minus 2. Since there are no common factors between the numerator and denominator, the product is already in its lowest term. Illustrative example number 3. Divide k squared minus 25 over k plus 5 and k minus 5 over k squared plus 6k plus 5. First, get the reciprocal of the divisor, k minus 5 over k squared plus 6k plus 5, which is k squared plus 6k plus 5 over k minus 5. Write as multiplication and factor expressions that are factorable. So the factor of the numerator of the dividend k squared minus 25 are the quantity k minus 5 times the quantity k plus 5 over k plus 5 times the factors of k squared plus 6k plus 5 are the quantity k plus 1 times the quantity k plus 5 over k minus 5. Cancel common factors between numerator and denominator before multiplying. So the common factors are k minus 5 cancelled out and another k plus 5. So the remaining factors are k plus 1 and k plus 5. So we may write this as a trinomial using the FOIL method, in which we multiply the first terms, k times k squared, outer terms, k times 5, 5k, adding to the product of the inner terms, which is 1 times k, we have k, so that's why we have 6k, and then last terms, 1 times 5, we have 5. Therefore, the quotient of k squared minus 25 over k plus 5 and k minus 5 over k squared plus 6k plus 5 is k squared plus 6k plus 5. For learning task number 2, so given here are indicated operations. So you may try answering this in a separate sheet of paper for practice and understanding. You may refer to the module for the key to correction. To be able to solve a problem solving on rational algebraic expressions, you have to make a rational equation. To make rational equations, you must translate a word problem into a mathematical sentence. So for the application, let us solve this problem in this particular example. 7 divided by the sum of a number and 2 is equal to half the difference of the number and 3. Find all such numbers. Letter A. Find what is as. Find the numbers. Letter B. Write all the given. Note, use only one variable. So the given are 7 over x plus 2. That is 7 divided by the sum of a number and 2. So 7 over x plus 2. And then half the difference of the number and 3. So when we say half, we divide a certain number and then difference of the number and 3 is shown as x minus 3. And then find all such numbers. So for letter C, write the operation to be used and the equation to work on. So we have 7 over x plus 2 equals x minus 3 over 2. So write the solution, apply cross multiplication. So we multiply x plus 2 and x minus 3. And also 7 and 2. So we have x squared minus x minus 6 equals 14. And then equating this into 0, so we have x squared minus x minus 20 equals 0. And then x minus 5 times the quantity x plus 4 equals 0. So we have the values of x as 5 and negative 4. And then for the last step, write the final answer. If x equals 5, the number is 1. And if x is negative 4, the number is negative 7 halves. For learning task number 3, 4, and 5, this will all be answered for practice. So make sure that you have answered all of this before proceeding to your worksheet assessment and journal writing about the topic. Again, thank you for listening and have a good day ahead.